I just wanted to give a quick video of the idea of this 3D continuous fiber reinforced pipe CNC 3D printer thing, gelatinous amorphous specialist tool thing. The idea here is that you have a bobbin of, for example, Kevlar twine. Kevlar is usually used in cloth rather than just individual strands. However, if you look up the GA boats, geodesic aerolite boats, geoboats.com, you'll find that yes, you can indeed get Kevlar twine or hemp fibre instead, and continuous strands. And what you do is you have a CNC lathe with a large pipe represented by the red marker pen that's buried in the middle there. That will be, for example, a 10mm diameter steel rod, and that will be what is clamped by the CNC machine. And around that you would have some smaller tubes represented by the straws. Around that you would have either paper or duct tape with the sticky side out, and you have a bobbin containing your twine, which will move along such that as the CNC is turning, the twine will be wrapped around, and then when it gets to the other end, it will wrap the other way, and you will end up with, similar to the garden hoses, the see-through garden hoses that you or your car hoses, in which you can see twin wrapped fiber reinforcement in through the see-through plastic of the pipe, the rubber pipe. That is exactly what we are looking to do. Then just over the top of this there will be a 3D printed head. Of course I've only got one hand at the moment, so I can't put that thing, which will splurge out 3D printed plastic along the top in straight lines, covering the twine, one line at a time, and then when it gets to the end it goes beep, and then back again, beep. So you're using the CNC axis to twist and turn the pipe, but you also have a standard Mendel 90 style or Prusa style XY arrangement, which just goes backwards and forwards, but instead of the bed moving backwards and forwards like this, it turns like this, okay, using the CNC. All right. So when you've gone round, all the way round, and done one layer, you move the printer head out the way, and you do another layer of twine, another thing of twine. Wind, 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 wind like this, and then wind in the opposite direction to give you the thread. You're in a crosshatch pattern. You do it several times. Zip, 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 zip. All right. Then you go back to doing yet another layer of 3D printed 3D printed plastic. All right. When that's all cooled down, this will be tricky. I apologise. When that's all cooled down, is that what I need? Okay, right. When that's all cooled down, what you'll be able to do is pull the metal former out the middle, drop all the straws out. Now you have your 3D printed plastic pipe, fibre-reinforced plastic pipe, with multiple layers that I would expect to be as strong as a carbon fibre, strong and as stiff as a carbon fibre pipe. Now, what is interesting is that at the end here, on this, you can put a threaded metal pipe that fits onto here, but it would be some suitable diameter relative to the final diameter of the plastic pipe that you want to create, which will be whatever it is you want, the outer diameter. And you basically embed the threading or the clicking arrangement, the metal piece, in the plastic, so that the plastic and the twine are wrapped around and form the thing, and encase that and join it to the pipe in a structurally strong fashion. And in this way you'd be able to have threads on the end that will go into standard nuts, or a locking arrangement if you 3D print the metal or find something cast or whatever it is you want. And in this particular case, what I would like to do is have a left-hand metal thread at one end and a right-handed thread at the other, such that when the pipe is turned, it will go into one node on the left and one node on the right, and it will twist in. You won't have to change the things. And what that particularly means is that when you're putting it in, you don't have to twist this one on the left hand side and twist the other thing, because you're going to have multiple pipes going out from these nodes, one over here, one like that, and at this end is going to be over the place. You absolutely do not want to have these nodes the pipes are connected into moving around, or having to twist them, or have some special mathematical arrangement. You just want to go twist, 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 and it comes out, or twist, 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 and it goes in. And to do that, you will absolutely have to have a left-hand thread at one end and a right-hand thread at the other, or a left lock mechanism at one end and a right lock mechanism at the other. So, little unusual, very specialist, but an important strategic modular design thingamy, blah blah blah, etc., etc., for constructing vehicles, buildings, furniture, anything that you can imagine, which can be constructed from a space frame thing. It's a 3D printed version of the stuff that is used commercially for making exhibition stands, and that's typically aluminium frame with hexagonal joints and 40-40 or 20-20 or 40-40 aluminium extrusion. Okay, thank you very much.